All right. So welcome, guys. Welcome. Sorry, some persons. All right. Please, if you can hear me, just drop a thumbs up. All right. Today's class is going to be very, very wonderful. We want to look at hybridization, and then we look at isomerism, and then we look at nomenclature of alkanes. Continuation. So these are the three topics we want to look at this night. And we are not just going to look at them, we are going to make sure we cover them in a very fast way. So please, if you can hear me, just drop a thumbs up. Now, these are topics that basically, if you're to learn it by yourself, it might take you weeks or months, or weeks or days. But then, in less than 2 hours, we're going to be covering this. In less than 2 hours, we are going to be covering this. So, if you're set, let's go. Please drop thumbs up. Let me be sure that you can hear me. All right, so let's start. Now in Jamb, let's talk about hybridization. We are solving past questions, all right? We are solving past questions. I have my past questions here with me. So I'm just going to quickly show us how questions can be asked under this. After that, we move into isomerism very fast. Now, when we talk about isomerism or hybridization, we have three types of hybridization in organic chemistry. Class, remember, this is a marathon class, so I'm not going to be teaching you as if, right, you've been learning for 6 months. No. What I just need to do for you is those parts I know that you need to just pass the exam. That's what I'm giving to you. So whenever you see hybridization, just know that we have three types of hybridization, right? The first one is sp3, the second one is sp2, the third one is sp. Where can we find sp3? Anytime you see a compound that has carbon-carbon single bond, that is where you can see sp. Or a compound name end with ane. If a compound name ends with ane, it means it contains sp3. The next one is you see a compound that contains a double bond, or that compound name ends with ene. That means it contains sp2. Then we have, anytime a compound name ends with alkyne, it means that is sp. Now, most common question Jan will always ask is that question 1, what type of hybridization is present in ethene? What type of hybridization is present in ethene? Once you see this, ene, that is an alkene. That means there is a double bond present here. Guys, what is the answer to that? The answer to that is sp2. Like I said, I want to show you guys how you can cover a textbook in short period of time. With what I have done now, I have summarized hybridization, right? After now, I will now define hybridization. Now, another question can be asked. There's a question I saw here. Let me quickly write it out. Now say, which of the following contain only sp3 hybridized carbon, hybridization? Which of the following contain only sp3 hybridization? A, butane. B, butene. C, butane. Class, remember, sp3 means that the compound contains only carbon-carbon single bonds. That is the meaning. Once a compound contains only carbon-carbon single bond, that is sp3. You may not have, read before now. Now, this is not the time for you to be reading as if you're in SS1. This is the time for you to adopt a pattern. All right? You adopt a strategy that will help you to pass your exams. Once you see sp3, just know that compounds that contain sp3, they contain single bond, and their name always end with ane. They will always end with ane. So if you look at this guy ends with ane. This one ends with ene, which is wrong. This guy ends with yne, which is wrong. So that is the answer for that. Okay, so these are basically Jamb nature of questions. Okay, please, if you're following me, please give me a thumbs up. If you're following me, give me a thumbs. Remember, this is a marathon class, so we are not going to be learning as if we are still trying to start. No, what I'm teaching you now, you should be able to use it to answer questions. Hybridization, what is the definition? It is a mixing. Hybridization is a mixing of atomic orbitals to give a hybrid orbital. So the mixing, when you mix S and you mix 3p, you have sp3. You mix S and mix 2p, you have sp2. You mix S and mix 1p, you have sp. Where can we find them? Any compound that contains single bond, or any compound that ends with ane, that is sp3. The one that ends with sp2, double bond, or ene, is sp2. The one that ends with yne is sp. Please, I need a thumbs up to be sure that you're following. All right. Now, let's look at something else. Still under hybridization. Class, look at this, because Jamb can be very funny. The shape. Now, what is a shape? Shape or geometry? sp3, listen, the shape of sp3 is always tetrahedral. with a bond angle of 109.5 degrees. The shape of sp2 is always trigonal planar with an angle of 120 degrees. The shape of sp is always linear with a shape of 180 degrees. You may be wondering, will Jamb come and ask me what is the shape of sp3? Never. Jamb will not. How would Jamb ask me that question? Now look at this. They will say, question 1, the three-dimensional shape of methane is dash. A, hexagonal. B, trigonal. C, linear. D, now if you notice, they use methane. Methane is a member of alkane. Any compound that ends with ane, guys, what I'm giving you guys is a code, is a cheat code, right? Not to cheat in exams, but something that can make you pass faster. Any compound that ends with ane belongs to alkanes. Any compound that ends with ane belongs to alkane. And what is the shape of that? What is the shape of this? Tetrahedral. What is the bond angle? 109. Any name of a compound that ends with ene is trigonal planar. What is the angle? 120. Any name of a compound that ends with yne, right? That is triple bond, alkyne. The shape is linear and the angle is 180. Now they said the three-dimensional shape, just forget about this. This is waste of your time. That three-dimensional is waste of your time. Go straight to the point. The shape of methane is dash. What is methane? Methane is ane. And what is the answer to that? Tetrahedral. Because methane contains ane. So the answer to that is tetrahedral, which is any compound that ends with ane, the shape is tetrahedral. And what is the bond angle? 109.5. I believe you can see how in less than 15 minutes we are about to cover hybridization. Please write fast. Now look at this next question. The shape of the hydrocarbon CH4 is dash. Now look at another question. The shape of hydrocarbon CH4. Now, all you just need to do is, what is the name of this hydrocarbon? Does it end with ane? Does it end with ene? Does it end with yne? Every compound has a name. Now, CH4 is methane. That is what we just completed now. The same question, they have asked it two different ways. But if you understand it very well, you will grab them here. The same question, different times, two times, same year. The shape of the hydrocarbon CH4. First, what is the name of CH4? The name of CH4 is methane. We have done nomenclature, the first part. You can actually check up the video, or after this class, I'll post it on the paid member group. For those persons that have paid already, I'll post it on the group. For those that will intend to actually register, please send me a DM so I can add you to the group. We have already done the first part of nomenclature, so you shouldn't miss out. CH4 ends with ANE, and guess what, guys? What is the answer? So no matter how they want to do it, you will catch them. So we are done with hybridization. Now let's look at the next one. Isomerism. Let's look at isomerism very fast. Please, if you're getting value for this class, a thumbs up would do, please. Just give us a thumbs up. Okay, for those that are not seeing the board, I've adjusted it. All right. So let's look at the next one. Isomerism. Now we have two types. Now under this guy, Jamb said we should only look at, we are just going to look at, okay, let's look at chain, positional, and functional group. Now under this guy we have optical, all right. So I want to talk about geometric first. I want to talk about geometric before I come down to this guy. Sorry, this is not geometric. This is please, this is stereoisomerism. So let's talk about optical isomerism, and then we're going to talk about geometric. Class, what I'm doing right now is that I am not interested whether you're good in chemistry or whether you're good. With what I'm doing, you should be able to solve questions when you see them. All I just need you to do is to pay attention. Remember, it's a 45 days marathon class, so you don't expect me to be teaching you step by step like as I'm teaching SS1 student. The one I'm going to teach, you're still going to grab it. You should be able to solve your past question. So I'm giving you more like a summarized teaching, right? Something that if you're to read in your text, it will take you time. I want to start with this guy. Now, optical first. Now, these are compounds. First thing first, what is isomerism? What are isomers? Isomerism is a phenomenon where two or more compounds have same molecular formula but different structure. Now, what is isomerism? Because I said we want to do isomerism. What is isomerism? Isomerism is a phenomenon, right? A case where two compounds with same molecular formula but different structure. Okay? One part of me is telling me I should start with this, but I'll leave this part here. All right? So let me quickly. We have two types of isomerism. We have the structural, which what Jamb is telling us to cover. We also have stereo. Under the structural isomerism, we have three types. We have the chain or the skeletal. We have the positional isomerism. And we have the functional group isomerism. Remember, we want to look at isomerism. Isomerism is a phenomenon where, I believe you should be writing, it's a phenomenon where two or more compounds have same molecular formula but different structure. First, what is molecular formula? Because if they say something have molecular formula, you must first of all understand what molecular formula is before talking about the structures. Now, good and fine, I'm going to be telling us what molecular formula is. But before then, I need us to take note that we have two types of isomerism, structural and stereo. Under each of them, we have three different types. Under the structural, we have chain, positional and functional group. And under the stereo, we have optical and geometric. I wanted to take this part, but I'll leave it here. Now let me quickly do the structural so that you get to see how isomerism works better before we now move down to this. Now let's say, for example, C4H10 has two structures. We have the first one. Guys, have you ever asked yourself, why is it that whenever you're writing a compound, some carbon will have 3 hydrogen, some will have 1, some will have 3? Have you ever sat down to think about it? Why is it that CH, you can never see CH5? Like, why is it that you can never see CH6? Why is it always CH4 and below? Carbon cannot hold more than 4 bonds. Now look at this. Carbon is tetravalent in nature. Tetra means 4. Valent means number of electrons used in bonding. But ignore this one for now. Let's stick to 4. What it simply means is that the maximum number of bonds carbon can hold is 4. Maximum. Nothing more, nothing less. So the reason why you see some compounds have carbon with 3 hydrogens, why some has carbon with 2 hydrogens, why some have carbon with 1 hydrogen, I'll show us briefly, because it's going to really help us to understand this guy very well. Class, if I have C, 3, 4, at least one bond need to join all of them. At least one bond. Carbon can only hold maximum of 4 bonds. Carbon A, carbon B, carbon C, and carbon D. If carbon can hold maximum of 4 bonds, carbon A is having just 1 bond. So this guy needs 1, 2, and 3 to make it up to 4. And these 3 bonds will be taken by hydrogen. Carbon B has 2 bonds, 1, 2. So it means that this guy can take more of 2 bonds. which will be taken by hydrogen. Carbon C is still attached to two bonds, this and this. So you have this, hydrogen and hydrogen. Carbon D has one bond. So you need to add 3 to this one to make it 4. We added 2 to this one because this carbon is already having 1, 2. So you just added 3 and 4. Each carbon must hold 4 bonds. So the reason why we added one hydrogen here, is because this guy has 1, 2, 3. So for you to complete this guy 4, you just add 1. This guy has just one bond, so you just add 3. This guy has 1, you add 3, and you add 3. That is it. Now let's come back to this. These two compounds, they are isomers. What do I mean? These two, they have same molecular formula of C4H10. How? First, what is molecular formula? Molecular formula is a formula that shows the actual number of atoms of each element present in a compound. It's a formula that shows the actual number of atoms of each element present in a compound. How many elements are present here? 2 elements. This compound contains 2 elements, carbon and hydrogen. How many carbons can you see here? 1, 2, 3, 4. 4 carbon. How many hydrogen can you see? 3 plus 2, 5, plus 2, 7, plus 3, 10. So it's telling us the exact number of atoms of each element. If you look at this guy, C, 1, 2, 3, 4, C4. Hydrogen is 3 plus 3, 6, plus 3, 9, plus 1, 10. So these two, they have the same number of carbon and the same number of hydrogen. But if you look at their structure, if you look at the way they are written, this guy is written straight, while this guy has branch. So those type of compounds that they have same molecular formula, but their structure is not the same, is what we call isomers. Please, if you understand this explanation, please, I need a thumbs up. Let me know you're following me. Remember I said we are covering 3 topics tonight. Joy said, I am lost a bit. Please, where are you lost, Joy? Please, if you have any question, just drop it on the comments. If I teach, I'll come and check the comments. Majority of us are following, right? If you have any question, just type your question. When I come, I'll pick it up and I'll explain it again. Now, for those persons that are following, right? All of this, you don't really need them in exam. I'll give you a shortcut for this. Somebody asked, what is the minimum number of carbon that can have an isomer? The minimum is 4. Minimum is N equals to 4. For alkanes. Minimum is N equals to 4 for alkanes. N equals to 4. After this class, I will drop a video on the group. Listen. I'll drop a video on the group. Now, what is the work of that video? All the things I have said here, I already explained that in a recorded video that we did before now. Okay? So, like I said, this class, I made it free. If I was teaching just my student alone, fine, that would have been different. But I made it free. That means everybody is taking part so that you can see how our class is running. So if you don't understand this very well, you don't really have to stress yourself. But just try and understand what I'm saying. You may not get the concept. After this class, I'll drop a video for you. All you just have to do is sit back, fold your hands, and enjoy it. It's not much. 15-minute video. All of this will enter your head. Everything. Class. Now, if you look at this is under chain isomers. Remember, I said that structural isomers is divided into 3: chain, positional, functional group. Since we have new persons in our midst, I think I'll just switch the mode of teaching, right? Let me do more of teaching and less past question mode just for today. From tomorrow, we continue again with our past question mode, because I'll teach first, then I'll solve question. Structural isomerism is divided into 3. The first one is chain, which is what we just did here. Now, what do I mean by chain? Chain, if you look at these two guys, they have the same molecular formula. But the only difference is that their chain is not the same. This guy is a straight chain, and this guy is a branch chain. That is the difference. A straight chain, a branched chain. Now, I said there is a formula for us to tell the number of isomers. Formula shortcut for determining number of isomers in exams for alkanes. So anytime they give you C4H10, this is butane, listen up everybody. Or they give you C5H12, or they give you C6H14, or they give you C7H16. This is pentane. Now let's do the shortcut, because at this point you need to be very smart. Please take note of these 4 compounds. Jamb must repeat this. C4H10 is butane. C5H12 is pentane. Just in case you're wondering how, why. Like I said, we already had a class on this, which after this video, I'm going to be sharing the video on our paid group, so that our students that have paid can use this night and actually watch this part and recap, get it for themselves. Now, with what I have done here, if they are rewatching that video, it increases their level of understanding, because they have heard of butane, so they are now looking forward to see butane. If they see butane, oh, so this was what Sir Delzy was talking about. That boosts understanding. So imagine you are given any of this, and you're asked how many isomers are present here. Now look at this. The formula to solve for that is 2n minus 4. Please take note of this. This is a shortcut where n equals the number of carbon. Note, n must be 7 or less. The minimum amount of carbon that can have chain isomers is 4. Now, in exams, if you're asked, we're going to look at past question after now, how many chain isomers or how many isomers is present in C4H10? How many isomers is present in C4H10? Now, in this guy, our N equals to 4. N is number of carbon. Number of carbon is equals to 4. Here, N equals to 5. Here, N equals to 6. Here, N equals to 7. Like I said, the full detail of all of this, I already made the video for this. Remember, we have started our class before this marathon class. So I decided to teach this one first. Then I'll send the video so that as you're watching it, it makes sense. If I send that video and say watch it before the class, you may not really have this enthusiasm to watch it. But since I have taught this and I've explained something that you're struggling to understand, when I now say go and watch this video, it increases your level of understanding. Do you get? Just like when a movie comes out, everybody's talking about it, everybody's hyping it, it increases your level to go and watch it. When you now watch it, you pay attention to details. But if you were not aware of it, if you're watching the movie, you will actually watch it casually. So that is a concept. I've actually given you guys a clue now. So here, if N equals to 4, how do you solve this? This becomes number of isomers in C4H10. Now here N equals to 4. So you now say 2N minus 4 plus 1. What is N here? 4. So this is 2, 4 minus 4 plus 1. This is 2, 4 minus 4 is 0 plus 1. Anything raised to the power of 0 is 1. 1 plus 1 is 2. Class, majority of questions I have seen in Jamb is always something you can use this formula to solve as long as chain isomer is concerned. So if you're here, if you're still contemplating or trying to, please don't do Jamb alone. Don't try to do Jamb alone. You will still pass, but imagine allowing somebody that have gotten the experience to drill you. Some things I can say leave this one, but if you're to do it by yourself, you may not have that confidence to leave it. What if they set it? But me, I'm telling you now that if you understand this formula, you can use it to answer a lot of questions. Okay? So please copy fast. If you have any question, I'm coming to check, so drop it on the comments. Okay, so we have, Esther. If they enable Esther, I can see you. I was even looking out for you. In your laptop, I can see you. Amina, I can see you. Amina said, so what is the lowest element that can have an isomer? 3 elements, 3 carbons. So, Yusuf Banki, I don't understand. Yusuf, can you be more precise? Which part don't you understand? Please, I'll take it again. I will. So let me take it again, everybody. All right. So for the sake of understanding and for the sake of our new students, let's take it again. Isomerism is a phenomenon where two or more compounds have same molecular formula but different structure. Same molecular formula but different structure. We have two types: structural, and we have, please everybody should pay attention. After this, I'm not taking this again. Under structural, we have chain, positional, and functional group. Here we have geometric and we have optical. Now we want to talk about chain. We are starting with chain isomers. This is the one we are going to talk about today. And after this class, I'll drop it. Like I said, after this class, I'll drop a video where you can actually take your time and rewatch all of this. Chain isomers, as the name implies, chain. It means, first, what are isomers? Isomers are two compounds or more that have same molecular formula but different structure. Molecular formula, the number of atoms present, they are the same. But the only difference is that the structure differs. Now, in chain, their structure is going to differ in their chain arrangement. And I gave you an example of chain. Example, C4H10. This guy has two isomers. C4H10 is butane. And I said it has two chain isomers. How did I know? Now this is a structure of butane. 1, 2, 3, 4. So you put here to be CH3, CH2, CH2, CH3. The second structure is 1, 2, 3. I already explained why this guy is 3 hydrogen and H2. If you look at these two compounds, they have C4H10. They have the same number of carbons. They have the same number of hydrogen. This is 1, 2, 3, 4. 4 carbons. 3 plus 2, 5. Plus 2, 7. Plus 3, 10. This one have 1, 2, 3, 4. 4 carbons. 10 hydrogen. 3 plus 3, 6. Plus 3, 9. Plus 1, 10. Which is this. Now, I now say in exams, they will not necessarily ask you to show the structures. Jamb is OBJ. So most likely, how will they ask you the question in exams? The questions will come as, how many isomers are present in C4H10? Once you see C4H10, it is left for you, it is your job to be able to tell, oh, this guy is butane. And it's not a rocket science. I'm telling you now, so you need to take note of it, because this is not a case of, this is a real compound. This is a real Jamb question. So take note of this. You don't have to cram it, but look at it and know it. This is butane. Butane. Please know this, because Jamb repeats this question. I have past question here with me. I have seen this question in Jamb past in the last 5 years. I've seen it up to 15 times. So please take note of this particular question. Now, how do you solve this? I said there is a shortcut to find the number of chain isomers. And what is that shortcut? 2n minus 4 plus 1. Alright? 2n minus 4 plus 1. Now you come here and say, where n is number of carbon. And I say, note, n must not exceed 7. If it exceeds 7, this formula will no longer work again. So this formula is best when n is 7 or below. So for us to get this answer now, I'll say for C4H10, the number of carbon is 4, which is this n. So therefore, number of isomers is now equal to 2n minus 4 plus 1. Anywhere I see n, I'll put 4. This becomes 2 raised to the power of 4 minus 4 plus 1. 4 minus 4 is 0. So this is 2 raised to the power of 0 plus 1. Anything raised to the power of 0 is 1. 1 plus 1 is 2. Snorkel. 1 plus 1 is 2. Snorkel. So that's the answer. Now look at this. The next one, for C5H12, this guy is pentane. In case you're asked how many isomers are present in pentane, now this is what you're simply going to do. Use this shortcut using 2n minus 4 plus 1. N in this case is 5. N equals to 5. So this becomes 5 minus 4 plus 1. This is 2 raised to the power of 1 plus 1. That is 3. Now question 3. What if they had said for C6H14, that is hexane? When I was going through the Jamb syllabus today, Jamb said we should stop at 6 carbon. So I'll stop here. Jamb said stop at 6 carbon. So I will not go and overstart. I will not go and start stressing myself. So I'll stop here. Here, n equals to 6. So this is 2n minus 4 plus 1. This is 6 minus 4 plus 1. 6 minus 4 is 2. 2 raised to the power of 2 is 4. 4 plus 1 is 5. So C6H14 has 5 isomers. C4H10 has 2. C5H12 has 3. So we are done with this part. Now we are done with chain, remaining this. But looking at the past question, this doesn't really come easily. So I'll just move to this next part. For these other ones, the video will be dropped on the group, paid member group. Please, the person that said he or she did not understand, is it better now? Yes, the formula does not work for all. I just said it now. It only works for chain isomers. Please, the formula only works for chain isomers. The formula only works for chain isomers. Now let's quickly talk about class. Listen, like I said, this our class is always videos and live classes. Live classes like this put us on the right track. The videos help us to understand better because everybody don't follow at the same pace. Like I said, after this class, immediately I finish this class, I'm dropping the videos of this in the group. But unfortunately, I will not drop it in the general group. It's only for those persons that have paid. Right? So if you actually want to join the class, maybe you don't have the full payment. You can say I'm teaching. This is my room where I teach, my teaching space. So for those persons that are thinking, oh, what if you check my YouTube channel, you can see where I've been teaching. So you can make part payment. If you don't have full payment, you can pay parts. I add you to the group so that you don't miss out. Because once I'm done with this, I'll post the video on the group. Now, I'll leave out this guy. Let's talk about this because Jamb did not really pay much emphasis on this. But that does not mean we are not going to do it. When you watch the video, you're going to see how I explain this. But let's focus more on the ones Jamb actually said we should do, which is these two now. Now let's look at optical. All right. So we have this optical isomers. Now, class. Only compounds that contain chiral carbon will exhibit optical isomerism. Only compounds that contain a chiral carbon will exhibit optical isomerism. First, what is optical isomerism? Optics means light. So optical isomers are compounds that are light sensitive. They are compounds that are light sensitive. Now, not every compound will actually be called optical isomers. What is the number one criteria that a compound must possess for you to say that this guy is an optical isomer? There's a question in Jamb. This is a question. I extracted the question offhand. For any compound to be called optical isomer, it must have what we call a chiral carbon. It must have what we call a chiral carbon. What is a chiral carbon? Carbon with 4 different subsequents. A carbon atom with 4 different substituents is a chiral carbon. Example of a chiral carbon is the, look at this compound. This is from Jamb past question, and the question was, the compound below will exhibit dash isomers. A, chain. B, optical. C, geometric. D, positional. Remember, once you see a question and they say this compound will exhibit, once you hear this compound will exhibit, your mind should quickly come to this. Anytime you hear this compound will exhibit, first your mind should come to either geometric or optical. Now, if you look at this compound, it has a chiral carbon. This carbon at the center is chiral. Why do I say it's chiral? Because it has 4 different substituents. First, now this is substituent 1, substituent 2, substituent 3, substituent 4. All of them are different. This is not the same thing as this. This is not the same thing as this, and this is not the same thing as this. So this compound will exhibit optical isomerism. Why? Because it contains a chiral carbon. What is a chiral carbon? Carbon with 4 different substituents. Example of that is this carbon. So the compound will exhibit optical isomerism. With this, I have completed optical isomers. This is what you will spend hours reading in your textbook. In less than 5 minutes, I have covered it. So just in case they ask you in exams, what is a criteria for a compound to exhibit optical isomerism? A presence of a chiral carbon. What is a chiral carbon? Carbon with 4 different substituents. Okay? Somebody said, is there a case where the number of carbon is more than 7, and what formula can we use? Yes, but Jamb specifically said we should stop at 6. Jamb said we should stop at 6. That is why. Alright guys, please can you see here? Alright guys, please can you see hear me? Anthony, sir, I don't understand. Please explain again. No, you have to rewatch the video. Please, well, I have a problem, a little problem, so I want to confirm. My mic, my phone battery is low. Unfortunately, I didn't charge it much today because I just came back from another. So my phone battery, my phone is low, so I'm charging it. So I want to check if my voice is filtered, like if it is loud or it's still something we can proceed with. Please, is it quiet? Is it or there is noise in the background? I would love to know. Please, just let me know. Can I continue like this, or should I have to wait until the mic is off? Please, let me know in the comments. All right. Somebody said it's chain isomer. For now, based on what I have seen in past question, I'll just take this. Please, this one now, when I send a video to the group, you can now watch this guy and this. So I don't want to spend my time for tonight solving this when I already have a well-detailed video. And Jamb did not really specify on this, so I'm only targeting what Jamb really specifies this on. Alright? This is not a time to be doing all round. This is a time for us to use a funnel pattern of reading. This period is using funnel pattern of reading. From the beginning of Jamb, you were reading everything, right? Now, as Jamb is closer, you should actually channel your reading towards a direction. So, beginning of Jamb, you were reading, everywhere. But now, you need to channel it to somewhere. Funnel, I call it funnel pattern of reading and teaching. Alright? So that is why I want to leave out this. But when I send the video, you can watch it up. Alright, so let's look at geometric isomerism. First, geometric isomerism is also known as C-strands. Maybe before now, you've been hearing of C-strands. You did not know that it is geometric. So another name for geometric isomerism is C-strands isomerism. So maybe if you go to your past question, you see C-strands. Basically, we are referring to geometric isomerism. Now, what are the compounds that exhibit geometric isomerism? Remember, when we talked about optical, we said for any compound to exhibit optical isomerism, it must have a chiral carbon. It must have a chiral carbon. It's a criteria. Like if chiral carbon is not there, that compound will not undergo optical isomerism. And what is a chiral carbon? Carbon with 4 different substituents. And I gave the example this way. Now we are talking about geometric isomerism. We said, or I am saying that for any compound to exhibit geometric isomerism, that compound needs to be an alkene. Alkene means it's ending with a double bond. Carbon-carbon double bond. It's a must. But that is not the only criteria. That is not the only criteria. Now, maybe you've seen something like this before now. Class, these 2 carbons are the 2 carbons of the double bond. For any compound to exhibit geometric isomerism, please listen to me. Listen to me. The 2 carbon, each of these carbon, they must not have the same substituents. If this guy is having A and this guy is having A, it is wrong. They must have different substituents. Now, what is correct? A, B, A, B. So if you want to write, you can say, for any compound to exhibit geometric isomerism, each of the carbon of the double bond must have different substituents attached to it. Each carbon of the double bond must have different substituents attached to it. A and B are different. A and B are different. This guy will undergo or will exhibit geometry. A and A are the same, this guy will not exhibit geometry. So for any compound to exhibit geometric isomerism, number one is that they must have a double bond. Number two is that each of the carbon of the double bond, individually, must have two different substituents, A and B. It may not make sense now, but let's take an example so that you see what I mean. Please, somebody say, when are we doing physics? Physics is on Wednesday. Tomorrow is English. Please, this is our marathon class mode. Last week, I was a bit slower. But since Jamb is very close, I want to increase my pace. So like I said, after this class, I'll drop a video, right? And also, if you have not yet made up your mind to join us, please do that so that I can get a lot of benefits. I've been working throughout last week, getting past questions ready. I would have dropped it on Sunday, but it was not yet to what I wanted it to be. So example is CH3. Now this is example of compound that exhibits geometric isomerism. The two carbons of the double bond, each of them, let's call this guy carbon A and carbon B. If you look at carbon A has this as a substituent, which is not the same thing as the second one. The two substituents on this carbon is this and this. And if you look at them, it's not the same thing inside the circle. This is CH3 and this is H. If you look at this guy, we have CH3 and we have H. Same thing. This carbon here is attached to this and it's attached to this. So this guy exhibits geometric isomerism. Please, if you understand this concept of geometric isomerism that I just explained, right? Please drop a thumbs up. If you understand this concept of geometric isomerism that I just explained now, please drop a thumbs up. Let me know that you can hear me and that you're following. Please, is my voice echoing? Was it echoing? Let me know if I should stop here. Is it something I can continue with? Was it echoing? Somebody said, "Sir, is this the only criteria?" Yes. This is the only criteria that you need to know if a compound will exhibit geometry. Now, please let me explain this again for the sake of those persons that did not. I don't like when some persons are following while some others are not following. I don't really like it. Okay. I said geometric isomerism is also called C-strands. For any compound to exhibit geometry, how would you know? They will say it. We will take some questions. For any compound to exhibit geometric isomerism, it must have a double bond. That is, it must be an alkene. being alkene is not enough. It must be in such a way that for something to be called alkene, it must have a double bond, carbon-carbon double bond. It's a must. For anything to be called alkene, it must have a carbon-carbon double bond. It's a must. Okay? Now, that one is not just enough. Each of the carbon of the double bond must not have two same type of substituents. Example, I have C. If I have this, this will not exhibit geometric isomerism. This will not. Why? Because this carbon of the double bond is having same substituents, H and H, which is something I said A and A. This guy will not. Even though this other carbon is having different substituents. This one is having CH3, CH2, while this one is having CH3. Even though this part is having difference, for the fact that there is similarity here, it will not. Now the next one is, what if I have CH3 we have this. Now this and this, they are different. This and this, they are different. So yes, this guy will undergo geometric isomerism. Okay. Now, how do we name geometric isomerism? How do we name geometric isomerism? Now look at these guys. Please pay attention. Geometric is named as cis and trans. Now, when do we call it cis? So we said, when do we say a compound is cis? When two same type of substituents on both double bond carbon is on same side. When two same type of substituents on both carbon of the double bond is on the same side. When is it trans? When two same type of substituents on both carbon is on opposite side. Let me show you this.
if you look at CH3 is on opposite side, same as H. So this guy is named as 6 because on both carbon of the double bond, CH3 is down on this guy, CH3 is up, so they are on opposite side. For H is up, H is down, they are on opposite side. So how do we name it 6? Whatever the name of this compound is. So 6 is when you have two same type of substituents on both carbon of the double bond that are, sorry. This is same side. Please, this guy is trans. Please, sorry for that interruption. When two same type of substituents on both double bond carbon is on opposite side, that is trans. Please, not cis. Cis is when they're on the same side. H is up, H is down. That is trans. CH3 is down, CH3 is up. That is trans because you're on the opposite side. Now, what if you have something like this? Now, this is cis because this and this, they're on the same side. This and this, they're on the same side. This is down, down, up, up. So cis is when they're on the same side. Now look at this. When two same type of substituents on this carbon, CH3 is same as CH3. Both of them are on the same side. Down, down. So in this case now you call it cis. When they are on opposite side, you call it trans. I don't know if you understand what I'm saying. My mic is making me feel like I'm not communicating properly. But if you understand this cis and trans, please, a thumbs up will help me to know that you are following. Please, a thumbs up. If you understand the cis and the trans, I need a thumbs up, please. Alright, for those persons that are asking for my number, this is my phone number. Our friend from India, you are welcome. We have students that is always watching us from India. Thank you very much for always, joining us. So please, if you have any question, please drop it on the group. If you have any question, drop it on the group. All right. Now, let's look at this example. Butene can be either cis butene or trans. Now, let's see how a question can be asked. Now listen, class. We may not be able to take all the questions, but I promise you once I'm done with this class, I'll snap the questions here. I've already filtered them out. I'll snap based on what we have done this night, I'll filter questions, right? And then I'll drop videos. So if you're not on the paid member group, please try and do so for your own benefit. So now look at this. They can ask you and say, cis and trans. I'll come back to this question. Cis and trans are dash isomers. I am not interested in whatever is attached. Once you see cis and trans are dash isomers, the answer it should not even stress you. It is geometric. Cis and trans are geometric isomers. Alright? Most common example of cis and trans is always cis but 2 in or trans but 2 in, which is what we have here. So now look at this. The normal way to write this is actually written in geometric form. The normal way to write this compound is CH3, this CH3, you put a line which is this guy, put C, put this H, put a double bond, put this C, put this. Now this is but 2 in. But anytime it is written in this format is what we call the geometric form. So this format is now trans which means that two same type of substituent, they are on opposite side. Whereas this guy is cis but 2 in. So one of the ways question can be asked is this. Remember, I will always show you how questions will be asked. One of the ways is this. Now, what is the second way a question can be asked? Let me show us. Now, this is the second way question can be asked. Which of the following will exhibit geometric isomers or isomerism? Which of the following will exhibit geometric isomerism? First thing first, class, please pay attention. I've shown us the first way question can be asked. They can ask you, cis and trans are dash type of isomers. The answer is geometric. The next one they can say, which of the following will exhibit geometric isomerism? Now, class, let me guide you properly. I want to cross out the wrong answers. Remember I said, for any compound to exhibit geometric isomerism, it must be an alkene. That was rule number 1. That is, it must be an alkene. So come to this option. Anyone that is not ending with alkene, E-N-E, is wrong. Butane is A-N-E, alkane. This guy is Y-N-E, this is butane. So these two is wrong. That leaves us with but2N and but1N. Now, but means 4 carbon from butane. We already did this. but the video is available. Boot means 4 carbons. 1, 2, 3, 4. So let's also do this guy. 1, 2, 3, 4. In means that there is a double bond. Once a compound ends with ENE, it shows that there is a double bond. But the double bond is at position number 2. So this 1, 1, 2, 3, 4. You come here, the double bond is at number 2, you put this here. But in this case now, boot is 1, 2, 3, 4. In means there is a double bond at number 1. So you number is there 1, 2, 3, 4. You put this guy, the double bond here. Anytime a double bond is at the end, listen to me. Anytime a double bond is at the end, that is 1 in, 1 in, don't even bother, that is wrong. Because any double bond that is at the end must have hydrogens. I remember I said, once for a compound to exhibit geometric isomerism, the 2 carbons, each of them must not have same type of substituent. This is the same thing as this, which makes it to be wrong. So anytime you have in double bond at the terminal, that is wrong. That leaves us with this. Now, if you come here, this carbon is having 1, 2, 3. You add 1 bond here, which is hydrogen, So if you look at this carbon is having carbon and hydrogen, which is different. This carbon is having hydrogen and carbon, which is different. And this becomes the answer. And as a matter of fact, we have been doing but2in all this while. Look at this. Cis but2in, trans but2in. So in summary, any compound that ends with ANE will not undergo geometric isomerism. Any ones that ends with YNE will not undergo. The ones that ends with in, look at it carefully. This one, anyone that has position 1, that is 1 in, run away from that. Run away from that, because that cannot be the answer. Okay? So guys, I'll stop here for today. We've passed this 1 hour 35 minutes. But this is what I'll do for us. The class was supposed to end by 11. So I'll drop the videos immediately after this class. Please run through the video. Don't wait till tomorrow. I'll snap this page of past questions. I'll send it and I'll tick the part I want you to answer. Remember, I will do my part, you do your part for you to actually smash your exams. Tomorrow is English by 8:30. Wednesday is physics. I'll be back here on Wednesday to break down physics. Okay? So if you have any question based on what we have done so far, please drop it in the comments. I'll come and check it. Do not forget that the comprehensive video of this will be posted on the group immediately after this class. Please watch it so that all we have done now can sink into your head perfectly. Thank you very much. This is my phone number. You can text me if you want to make payments to join our paid member group. I promise you, your Jamb, you're going to actually pick up. You're seeing the difference already. Right? We have videos of teaching. Today, I combine past questions and explanation. So see you guys tomorrow. If you have any question, please drop it on the comments.